It's only just now I realized that I'm the villain. I'm Vice President Product Management from Oracle, so yes, I have product management. I really enjoyed Alejandro's talk. It was very nice. Not only am I the villain, but I'm the villain from the megacorp Oracle. Ooh. But I'm conflicted though, because one of the topics today, my main topic actually, is to talk about how we've built AsyncAPI onto a product called GoldenGate. GoldenGate is, of course, the picture Alejandro used for the bridges. So our business with GoldenGate is to make bridges between software products, right, and databases. So I don't know, villain, hero, maybe at the end you'll tell me. So I know it's been a long day, so I'm going to go very fast. I wanted to talk a little bit about what is change data capture and replication, just very quickly. I want to talk a little bit about what the GoldenGate software is, sort of why we're here, why we're putting AsyncAPI on the GoldenGate. And then I'll spend most of the time in here kind of talking about some of the use cases for AsyncAPI that we're seeing with our customers. And then we'll tell a little bit about the roadmap and our experiences. So I'll try to go pretty fast. I think many of you already know what change data capture is, but I wanted to really just emphasize the point that we see change data capture as being an important part of the enterprise software architecture precisely because it works with transactions. So Kafka, for example, is not a transactional system when it comes to what's called DML. So database transactions are a very special type of transaction. When you make an insert, when you make an update, the database maintains the transactional consistency across what could be thousands of users, many rows affected on an update, and it keeps everything consistent while the database is processing. You'd have thousands of clients manipulating billions of records, and the database maintains the consistency of the transactions as well as the durability of the transactions. So when something fails, the application stops, we need to restart, we restart from the database, or the database provides the durability. So these types of transactions that we have in here, very important. It's the DML is the data manipulation, the DDL is the schema changes that we see, provides the consistency, and also the durability of the transactions. So again, for transactional databases, especially OLTP databases, this is very important. So change data capture is really about capturing the event in the database when the data is committed. So what we're doing is we're reading the events while the database is processing. We see the inserts, we see the updates, we see the deletes, and we capture that event, and then we can do something with it, right? So you'll see now with AsyncAPI, what we're doing is we're making those events from the database layer publish as streams, event streams coming from the database through an AsyncAPI interface. And that's where the replication comes in. I think in developer language, we'll talk about brokers, right? So essentially replication software is about being able to broker the transaction and send it over the network. So that's databases. So GoldenGate is actually one of the first CDC tools in the world. It was actually originally a startup in San Francisco. Started in, I think, 1996. And it's been around for a long, long time. Oracle purchased GoldenGate technology in 2009. Oracle purchased the technology for a couple of different use cases. One use case was actually to provide high availability across different installations of Oracle databases. We do logical replication in a clustered environment for databases. It was built to replace a couple of older technologies like Oracle Streams, Oracle Change Data Capture. And the second big use case for GoldenGate is we use it for data integration to feed data warehouses, data lakes, data marts, synchronizing between different databases, et cetera. So it's the core part of our data integration platform. So today, GoldenGate's a pretty big business. It's about a $1 billion business globally. We have around 10,000 customers globally using GoldenGate, mostly the biggest customers. Everybody here is probably making GoldenGate transactions every day. If you do a banking transaction, if you make a phone call, if you make an e-commerce transaction, all the payments platforms use it, global payments, et cetera. So GoldenGate is out there. It's usually underneath a lot of the systems that are there. But for GoldenGate today, we do support hundreds of different data stores, so it's not only Oracle database. In fact, a lot of the payments platforms that you do card processing on are probably running on something called HP nonstop systems, and GoldenGate provides high availability for HP nonstop systems. We provide high availability for SQL Server, for MongoDB, for a lot of things. So again, generally for distributed architectures across the network. We do other things besides replication. So we do data integration. We do stream data processing, similar to like Confluent, KSQL, or Flink. We have cloud data pipelines, data governance, real-time observability. All this is in the platform as well. But today we'll talk mostly change data capture and replication. Why AsyncAPI now? In the first 10 years of GoldenGate, focus for GoldenGate was mostly replicating database to database, okay? Asynchronous replication, database to database. It could be in the same one data center or many data centers, but asynchronous replication, database to database, okay? Next 10 years of GoldenGate, really with the emergence of massively parallel processing engines like Teradata, Netezza, Hadoop, where we have MPP data warehousing. Now we see use cases for data warehousing and big data, data lake use cases. Now we're replicating from the transactional system into the analytic MPP environment. So this is, again, asynchronous replication across the network. What we've seen starting back in around 2015 to today is a big shift in the way GoldenGate is being used. We see GoldenGate being used much more for microservices use cases. We actually refactored GoldenGate in 2017 to be a microservices architecture. We see GoldenGate feeding transactions into microservices applications. We see GoldenGate being used to feed transactions into Kafka, JMS, Pulsar, all sorts of things where the applications are now consuming the data events directly from the brokers. And then we see also the multi-cloud use cases. So the cloud use cases are, you know, somebody has an application running on AWS, but their data lake is on Azure. Maybe some other application is on-prem, but they want the data routed between the different data centers, the different cloud regions. They can replicate the transactions with GoldenGate. So for us, looking at AsyncAPI was actually a natural evolution, a normal thing for us to think about where to go so that it's part of an open standards approach that we're building on top of the asynchronous patterns for event-driven architecture, et cetera. So we see some of the use case. Again, GoldenGate is totally async end-to-end. There's no synchronous processing in GoldenGate. One common use case we see is for Transaction Outbox. I'll talk a little bit more about that. We also see customers implementing CQRS and Saga patterns using the replication technologies to move the payloads around. And then event streams, as all of you know very well, it's becoming a normal part of the architecture discussion for event streaming patterns and just generally speaking, the microservices. And so for us, we do work with Kafka. One of the challenges with Kafka that we've seen, we've had Kafka support in GoldenGate now for, I'm going to say like 7 years. So we have LinkedIn is one of our, actually we worked with LinkedIn originally. They came to us and they use GoldenGate for replication under the LinkedIn platform. Before Kafka was even contributed back to Apache, we were working with them on GoldenGate to Kafka. One of the challenges with Kafka, again, is it's not a transactional system. So when you move DML records into Kafka, you lose the dependencies between your record updates. And one of the normal patterns for Kafka is you do the change data capture, and you generally have one topic per table. But when you have things like foreign key relations and tables and you're doing updates where you have strong dependencies on the tables, when those go into Kafka, you lose all the transactionality of those. And so what it does is it puts the burden on the consumer to maintain consistency in the data. So you have to keep track of the records, what transactions were committed when, and then you have to reassemble the data. So this has been a big challenge. Another problem that we see with Kafka is in the event sourcing world, sometimes there's only one consumer. And so Kafka, I think, is still beautiful when there's many consumers, like a one-to-many or many-to-many. You're using it as a true kind of messaging bus. But many use cases we have to consume from another application. And so it's more like a one-app-to-one-app kind of thing instead of one-to-many. And so for those kinds of use cases, Kafka can be overkill because you have to embed HA, you have to manage all the partitioning, you got to do all the lifecycle management, everything just associated with running Kafka. So with GoldenGate, what we've done is we've taken the AsyncAPI standard and we've put this into a feature that we call data streams. So what we can do is we can capture the DDL and the DML from any of the various sources that we capture transactions from. Now, remember, these are push events. This is not polling. When we're doing change data capture, we're essentially getting the transactions on a millisecond level basis as they're pushed to us. You can think of it as sort of like tailing the logs, you know? For every database, every data source is different, but we're seeing the transactions as they're committed over here. We capture, and then what we're doing is we're now making them available as a streaming interface. So our payloads here are actually the streaming events. So we see the insert operations, the update operations, the delete operations, and that's all transmitted as payload in the AsyncAPI messages that we publish from our interface. So that gives any of the consumers access to real-time DML and DDL. Again, the schema events are also visible here, so you see all the schema changes on the source. We're able to use the code generators provided by the community. We're also working to maybe bring something back for a secure WebSockets implementation. I'll talk about that in just a minute. This enables the event sourcing, transaction outbox patterns on the broker side. For many of our customers, there's some value in bypassing Kafka, and we believe in AsyncAPI. We believe AsyncAPI is the future of asynchronous real-time event-driven architecture. So, two big use cases for us here. One is application consumers. So in this case, you have applications producing transactions, GoldenGate transmitting the streams as JSON records, and then applications consuming these. So we see this as the consumers. Typically, are going to be some type of application microservice. The second big use case for us is publishing the streams into data lakes and data lakehouse architectures. So we'll have a different format, and those can be fed into the ingestion layer, the bronze layer of a lakehouse, and then analytics can be run on the data downstream in the data lakehouse. So I know the question comes up a lot when I talk to people. So why would you bind your interfaces at the data level? And there's a couple reasons why many of our customers choose to do that. One is it's the commit point for durability. So the moment in time, the precise millisecond when the commit is committed in the data store, that's when data is recoverable. That's the point in time when it's durable forever, right? If you have designed the database the right way or whatever your data store, it could be Mongo or Cassandra or Oracle or whatever. So it's the commit point for durable data. What that means is that this is where you're going to get the lowest latency transmission. If you want to move the data as fast as possible, you don't want to move the data before it's committed, because then if your application crashes before the transaction commits, you'll lose data. If you want to move the data after it's been committed, maybe you have a polling architecture. Every 30 seconds, every 1 minute, you're reading from the outbox or something. Well, that's adding latency because now you're polling the tables and you have all the flow to commit the data and then read the data back out through a SQL client. So what we get with this type of approach with change data capture is you get the lowest possible latency to transmit the data events as they're happening. And then the third thing here is that we can automate the whole process. By doing it at this level, we can actually automate all the publishing process of getting the data out. We automate the construction of the schemas and the payloads, so you can now push the data to your consumers. So let's look at a couple of patterns here. What I want to mention, that I don't know if this translates in Spanish, but in the US we say there's no free lunch. No, and I'm talking about here for data bindings. That means somebody has to pay. Always somebody is paying for lunch. And so in the case of doing data bindings at the message level, the work either has to be done by the producer, or the work has to be done by the consumer, or I'm adding a third case here, sometimes it's actually done by the DBAs. Actually, and this is many legacy applications are written with interface tables to publish the data through the views of the database. And so we can support all of these patterns. So for producer-friendly data publishing, that means no changes to the applications, no changes to the base tables. What we do is we read the transactions from the logs of the base system, and then we publish those, the data and the schema changes, all in a stream of JSON objects that can then be consumed by the receiving applications. This logic in the receiving app, the consumer application, can detect the schema changes, and it can consume the payloads, the message format. So you see, again, all the inserts, all the updates, and the deletes. And so now you can consume those in the app. Now, the benefit for this is very easy for the producer. They don't have to change anything on the source application. They don't have to change anything in the schema. No outbox tables, no nothing like that. The schema metadata is here in the payload. So if people are worried about, oh, what if I add a column, or what if I change a column metadata or something, all of the changes are in there. You can decide on the consumer side if you want to react to those changes or how you want to react to those changes. Now, of course, the cons is that this is binding to the base tables. And I know, especially in the microservices community, sometimes there's purists out there that say, well, no. I don't want to expose my implementation details to the downstream consumers. So maybe for some people this is a negative. But again, this is a pattern that we see people using. For the consumer-friendly data consumption, I was really interested to see Ivan's presentation here. So let's say you have a transactional outbox built with ZenWave, right? So that would be up here in the application tier, and you're automating with ZenWave the process of doing the transactional commits with the JSON payloads in your outbox table. So you've got your outbox tables, you're constructing your JSON payloads, you save those in the outbox table. Now what we can do with the GoldenGate side is we read the logs over here. So as soon as the commit happens with your payload in the outbox table, we'll take that JSON payload and we're going to move it downstream to whatever your target is. Or in this case, we're publishing it on AsyncAPI data stream. So your consumer is subscribing to a channel, right? And they're going to receive that JSON payload over here. Now, depending on, I like the discussion also on like who owns the definition of the payloads. Sometimes the consumer says what the JSON definition is. They define the objects. Sometimes the producers decide what the definition of the payload is. We can support either way in this. Whatever the construction is on the message payload, you can receive it over here. But if it's been defined by the consumer, they don't have to do anything. They just consume the JSON objects as they've been defined. So obviously for this approach, it's easier for the customer, the consumer, if they're dictating the message or the JSON payload structure. This could be obviously favorable by so-called traditional microservices developers that want to isolate the implementation details separate from the outbox, right? So this gives you the outbox pattern. And then, but of course the negatives is that it puts the burden of the maintenance of the JSON objects on the producer side. So if something changes on the source application, the developer, well, if they're using ZenWave, maybe it's automatic. But for other people, maybe they have to recode the JSON structures. And then, so that can require some changes to the existing applications. So the third pattern that we see, this is really very common with a lot of legacy applications. So in fact, we were just earlier this week talking with Santander about their use cases. So if you have a legacy application, maybe in a mainframe or some old application, like everybody's retired and nobody's working on the code anymore, so they can't change this piece of it, but they've got something down here in their database. They've got their source schemas over here. But what the DBAs can do is they can create view tables that actually maintain the transformations from the third normal form to the interface tables that are being published for external consumption. Then we run change data capture on this process, make it available through AsyncAPI, and then the JSON can be consumed directly through the streaming interface there. So this, I was trying to think about how to explain when this is useful. For bigger companies, many times these are all different teams. Right? So the apps team could be under one organization. The DBA team is like in a shared service organization, different org. They just take care of the databases, right? And then you have your consumers that are also in different business units, right? So you have these different teams all over the organization. If sometimes it's actually easiest to actually just make the data available in this tier because the IT service organization can actually modify this, but they don't own the apps. And so that's something that we see come up every once in a while. All right, so how does this work? So in GoldenGate, the producer decides which databases, tables, and columns they want to publish. They use our administration microservice to set up the capture process to read the logs. And then they configure what's called our distribution service. You can think of this as the broker. We have a distribution microservice. The distribution microservice is what's publishing the async APIs. And so that sets up our pub/sub REST APIs to bind and consume the payloads. So on the consumer side, they're going to use our REST APIs or our user interface to browse the channels. That, by the way, every GoldenGate, what we call trail, is published as a channel. So there can be multiple channels per distribution service. So they browse what the channels are. They select which channel they want. We're going to give them the YAML document that they can use to generate the client bindings. So they generate the client bindings and then fill out the logic to process the payloads, and then they can begin consuming the transactions. So that's kind of what the end-to-end flow looks like for us. I'll give you a couple examples here. So this is the GoldenGate microservice, what we call the broker distribution service. So we have these objects called data streams. These are the channels, right? And so each stream is a channel. When we create new streams, we're essentially we're attaching the channel to an internal artifact in GoldenGate called the trail. The trail is what is defined as the which tables and columns you're capturing from, essentially. And so that's been defined. That's actually been defined earlier over here. I'm not showing you those screenshots. But once it's been defined, you just say, what is it? And then today, our default encoding is JSON. I'll talk about what we're adding more formats in the future. And then you can also define a quality of service. So we support exact once processing. We support at most once and also at least once. So your QoS can be defined how GoldenGate will behave in case of different breaks in the logs that are flowing. So GoldenGate is capable. This is important, right? For the use cases where you need high consistency, we can support the exact once processing model on the transactions. We can filter per channel. So let's say, for example, I have an outbox and I have different JSON documents that go on my outbox. I want one of my friends to only see certain payloads, only certain JSON documents. I can actually set up by object type or a value and then define the payloads which are visible on that channel. So I can have one outbox, multiple payloads, and then I can define a channel for each consumer to consume different payloads from a single outbox table. So that's something that can be set up here. Also, of course, you can filter by table, by column, et cetera. So you can define what's exposed. All right. So typically with GoldenGate, most of our customers use a secure WebSockets connection. And so one of the things that we're looking at building into the platform, hopefully contributing back to the AsyncAPI community, is a secure WebSocket implementation. Today, this is still in an Oracle developer's GitHub, and then hopefully in the next couple of months we can look at contributing this back and bringing it into AsyncAPI as well. But this is something that we have right now in our area. All right, what we're doing, I showed you before the screen with the channels and the streams. One of the things that we're looking at is, can we bring the AsyncAPI Studio into our JavaScript application? So this is all a JavaScript app that runs in a browser, and we're looking at bringing the AsyncAPI Studio in so that when I go in to my channels and I click on details, I bring up the Studio, and then the Studio shows me all the normal AsyncAPI Studio options. And that's something that we want to make available to our customers through the GoldenGate user interface. So today what our YAML looks like, we have 6 different schemas. We have a schema for the DML, the inserts, the updates, the deletes. We have a schema for the DDLs, alter table commands, add, drop, et cetera. We have object metadata and stream metadata, and then we have the parent types that essentially drive these. So that's what we put in our messages for the payloads. So this is what we've defined as our YAML. This is an example of the client code that's generated. So today, this is mostly interface, right? So all of this is just connecting and binding to our clients. This is where the data processing would happen. So today, I was interested, the presentation earlier about being able to generate objects for the payloads, from the message payloads was quite interesting. We don't do that today. We're just generating the stubs for the interfaces, and then our customers would have to implement the logic to parse the payloads, essentially. So this is what our payload looks like. So you can see we've got the qualified object name for the tables. We have the different op types, insert, updates, and deletes, timestamps, positions, and then for change data capture, usually what you get is you get a before image and you get an after image. So typically with like an update, you're going to see what that row looks like before, and you're going to see what the row looks like after. And everything here is typically driven by keys, but we can also use synthetic keys with GoldenGate. So that's what the payload looks like. This is what our JSON looks like in terms of the message construction. I don't have time. Again, options on the service, we expect most of the time will be used as a secure WebSockets implementation. I mentioned the payload service levels. We think most of the time people will use exact once. In the exact once model, GoldenGate will guarantee that you only get the transactions one time and every time. There will be some use cases where at most once processing may be tolerated. So if there's gaps in the streaming records, or in the at least once model, if you are okay with duplicates, then you may want to reprocess the duplicates. GoldenGate will send the duplicates through the AsyncAPI service. And generally, the start position is the other important parameter. When you connect to the AsyncAPI service, you can choose to start processing the stream at the current point in time, and you only receive the events going forward. Or you can go back to the beginning, and the beginning is defined by the producer. It could be 2 hours, 2 days, 2 months, whatever, of data that's held in the ledger. So GoldenGate is maintaining a ledger of historic transactions, and if you choose the earliest position, essentially it will start pushing you all the transactions that it has available to it, going back in time. So what we're looking at for the future here is adding more formatters for the application consumer. So that would be JSON, Avro, XML, protobuf, and typically those are the application formats for app messages. But on the analytics side, we also see a lot of interest and value in publishing more of the analytical data formats, which would be Parquet, Delta, Iceberg, those kind of things. So pushing into a data lake or a data lakehouse, I think like Databricks or Snowflake actually consumes Avro. But we're going to look at bringing cloud events in as the payload. So today we publish our own schemas that have been defined by us, and these are pretty close to what we process in GoldenGate. But in the future, we also want to provide a cloud events formatted payload that, again, should help further automate the generation of the code that processes our message payloads. Business object semantics. So we've been working on features actually in the Oracle database. It's called the JSON relational duality, so that your database is maintaining records in a relational format, but it's publishing transparently to JSON. And we'll be able to tie in with that so that the business object definitions inside the database are now published out. So you're not dealing at that point with physical tables. You actually just have the JSON payloads directly from inside the database. And then also stream processing. So I mentioned we have another part of the GoldenGate portfolio that's a little bit like Apache Flink or Confluent KSQL, something like this, or it actually runs on Spark Streaming. And so what we'll do is we'll put the AsyncAPI at the end of the pipeline. So as the data is coming in, we can do the stream processing in the stream with all the windowing technology for stream processing. And then what we'll do is we'll publish an AsyncAPI for the output as a sync to the pipeline, so that consumers subscribe to the pipeline sync, and they'll receive the messages coming out of that. So that's something that we have planned for the future. And that was it. So I hope that wasn't too much time. Happy to take any questions if there's an interest there. Long day. All right.
Well, thanks first of all for the presentation. I kind of have a bunch of questions and kind of also to raise awareness. So things I want to share. So we're in the process of rebuilding Studio UI, and I see that you have it embedded in your product.
Nice.
So let's make sure that we
Yes.
we align on this, because we don't want to break you. That's the first
Big
thing.
changes coming?
Yes, it's a big one, actually.
Okay.
So we're not getting rid of this, but yeah, it's changing. What else? So another one is to raise awareness is cloud events is going to be proposed. Actually, I'm going to be proposing it to be added to AsyncAPI 3.
Oh, okay.
3.1, 3.2, let's see, I don't know. At some point, not 3.0, otherwise this guy here will kill me. He was already like, what the fuck are you saying? So, yeah, and yeah, and I was curious, in one of your previous slides, if you can go back, please.
Sure.
Is one with the AsyncAPI symbol in the middle on the GoldenGate logo.
It was on one of the PowerPoint diagrams,
Yes.
like this one up here, but I think there's a bigger
this
version
one,
like
yeah,
that.
this one, exactly. So this one, like, I'm a little bit confused. So what are you doing exactly here with AsyncAPI? Are you, I don't think you're validating the data, because it's coming from the database already committed. It's already there, right? So what you're exposing is the AsyncAPI file, so that the consumers can get it, can use this AsyncAPI file as a...
And the interface is the AsyncAPI.
So the consumer knows what's the AsyncAPI definition of that stream, right?
So previously, before we did this with GoldenGate, GoldenGate did not support a subscription API. So AsyncAPI for us is essentially becoming the subscription API for consumers to subscribe to these event streams. Before, what GoldenGate would always do is it would push it. So like when we've been supporting Kafka, we have something called a Replication process that's actually pushing the data into the Kafka topics, and then the consumer would come to the Kafka topics and subscribe to the Kafka topics. So now with AsyncAPI, by putting this implementation here, we have a REST-based subscription API that's using AsyncAPI and defined by YAML.
Awesome. Yeah. Thanks. Yeah. That clarifies a lot. Thanks.
Cool.
Any more questions?
Okay.
Let's connect. Yeah.
Yeah, absolutely.
Thanks
Thank you guys. Appreciate your time. Yeah.